Good morning, followers. Good morning, members of the Econometrics, Applied Research and Capacity Building. This is the third video on simple survey data estimation. So the first one, we did a video on cleaning and preparation of data. And the second one, we did something on basic estimation. Then today, as a further estimation, which I could name as part 3 of our simple survey data estimations, or purely we are going to focus on something else, but it's an added idea for us to have a complete tutorial of our data sets. So we are going to use the same data. Let me import the data that we used. We browse. We say okay. This is the data that we used. So as it is, this is unclean. For the previous video, we've managed to clean the data. So let us quickly go back to our do file and see what we did so that we can just do estimation. To open your do file, you come to file, say open. You'll be able to access where you've saved your do file. This was the place where I saved mine under survey data analysis. You select, you say okay. So this was the work that we did. Quickly, we just highlight the rest of the commands for cleaning data. We get the data ready for further estimation. So we just highlight. It is good for you to go back to my first video on cleaning and preparation of simple survey data so you get the steps. But as it is, the next level to this level is further simple analysis. So we just execute to get the variables ready to do further analysis. We execute. You can see that we've got the data readily available for analysis. You may call this part 1 of the estimation process. Part 2 is purely basic summary analysis or descriptive statistics. And onto this level, this was the last part of our previous tutorial video. So today I may want to call it part 3. I may want to call it part 3 of basic survey data analysis. So in this video, what do we want to focus on? It's to generate age categories. Where to generate age categories. Imagine you have a data or you collected your data and the respondents have different age groups ranging from the young, middle, and the old age. So how can you generate variables that can group them into segments so that you can do basic analysis? That's the focus of this video. So to do that, the ages ranges from 20 years to 75 years. So let us group this into segments. First, what we are going to do, you ensure that you generate a variable called age group equals to dots. That's what we're going to do first. You highlight. This is the command for it. I've generated the command already, so it's like it just highlights because we are dealing with a group file. You execute. So if you come to the Stata data editor, you'll find out that we've generated a variable, but it has a missing value. So we need to place values under this indicator. So what we do next, the next step, we replace age group equals to 1 if the age is less than 30. So we want to create an age, whether it starts from 5 years, 6 years, 7 years, on to 30 years. So we create a variable, we create a value 1 if age is below 30. So make sure that you type age the way it should. So we highlight, having got it right, then you highlight. We'll say now, let us provide values. Let us provide value for the age group. So this is the command, replace age group equals to 1 if age is equals to, is less than 30. So we execute. Then the other next value that we want to provide or generate, we want to replace age group equals to 2 if age is greater than or equals to 30 and age is less than 80. So we want to create a category of group that exists between 30 to 60 years of age, of exponent age. That's what we want to do. So make sure that we type the variable the way it should be. Then age in cap, age in cap. This was not typed well, so let us type it well. So we execute as well. Or generate category 1, category 2. Then we say we replace further age equals to 3 if age is greater than or equals to 60 years. That means from 60 above, we are creating a category value for age starting from 60 to above. I think the maximum age is 75, so it's from 60 to 75. So all exponents falling within this age bracket will also create a variable for them, value for them, so that we'll be able to do analysis. So that's what we're going to do. Let us type age 1 because that's how it should be indicated here. Otherwise, we'll not be able to get the right command. So we highlight, we execute. Further, we want to do label define to ensure that we generate or replace the generated values 1, 2, 3 with different names. So we say label define age group 1 for young, 2 for middle age, and 3 for old age. So that we'll define the categories of different age segments. So what we do here, since that we generated the values, now we want to define them with a label characteristics. We highlight, we execute. Then finally, we end up with labeled values, age group, age, GRP, to finally have the process done. So we highlight this again, then execute. Having done that, let us see what we've done. Let's go to the edit browser and see what we've done. You can see that we've generated categories of age for middle age, old age, young. These are the three categories that we've generated. So for young group, ranging from say 1 as the case may be to 30, middle age starting from 30 to 60, and old age starting from 60 to the end part of or the maximum age group. That's what we've done. So once you be able to categorize your age in this kind of segmental approach, you now be able to do your analysis. So now let's go and see what we can do with the data once this categorical variable of age is available now. Let's do our basic analysis. First, before going to the analysis of category of age, let's do a basic analysis to understand gender differences in education. Although this has been done, just to spice you with idea, this has been done in our second video. So it is also good that you have that kind of repeated command or repeated output so that you understand the concepts. So let us investigate gender differences in education. This helps us to answer the question, do males and females differ in educational level? That's what this particular command helps us to understand. So let us use the tab and see what comes out. Tabulate, sex, educ. These are the variables. We want to see the relationship. Comma, then roll. Let us execute and see what comes out. Let us execute. So this is the output showing relationship between gender and education. So in gender group, we have female and male. Then in the columns, we have educational level. So we have a 0 level of education, which says that the population, or in this sample, we have people that have no level of education or just have pre-primary educational level. We have people that have a level of education at grade 7 or higher secondary school, then university, which is grade 10. So for female, the data shows that we only have 3 respondents that have no level of education, and no respondents that has a grade 7 level of education as well as grade 10 level of education. So the total respondents under this category for female is 3. So further, we also have for male, we only have 2 individuals that have no level of education, representing 40%. Then we have 2 people that have 2 people that have grade 7 level of education, representing 25%, and 1 individual at university level, 12.50%. So in total, we have 5 respondents that have no level of education for both male and female. Then we only have 2 individuals that have grade 7 level of education, representing 25%, while non-level of education representing 62.50%. Then for grade 10, we only have 1 individual in total, representing 12.50. So the total sample size here is 9. There is a missing value of 1. So this is just the relationship between gender group and that of educational level. So what next do we want to know under this data analysis? We may want to test statistics or statistical test. We may also want to apply statistical test to see the association. Maybe you are running a data, you want to test the relationship between two indicators. So in this case, we want to know whether the relationship between sex and education are significant. We want to know whether there is the relationship between these two indicators. The relationship between these two indicators is significant. So we use the same command. We highlight. We are using chi-square here to help us interpret. If the p-value is less than 0.05%, there is a significant relationship between gender and education. So let us see what comes out. It is the same command, but the only thing that we are focusing on here is the relationship test. We want to know whether there is a significant or non-significant relationship exists between these two indicators. That is education and that of sex or gender. We execute. So are these the same outputs? We don't need to waste time here. The same outputs, gender and educational level, where we have 3 female, no female for grade 7 level of education, no female in grade 10 level of education. Therefore, male we have 2 for non-educational level, then 2 for grade 7 and 1 for university. But what is the relationship? So we are saying that if the p-value is less than or falls within the 5% critical value or level of significance, then we say there is a positive, there is a strong relationship. But when it's greater than the 5% significant level, then we say there is no strong relationship between the two variables. So as it is, we have we almost have 24%. So there is no significant relationship between these two variables. Right. So you may want your data, your survey data, you also want to test relationship uh, between or among variables. So you can apply the chi-square to get results related to that. So what we want to do next, now we want to analyze the age group. Analyze your age groups for young, which is less than 30 years, and middle age 30 to say 50 or 60 years, sorry, 59 to 60 years. Then we have old age 60 plus. So that's the analysis that we want to do. And we can apply the tab command. We tabulate and see what comes out of it. We highlight, then you click, we'll see what is the result. So this is a simple frequency output. Young people representing 1. For young people, we have 1%, sorry, 1 frequency here with a percentage of 11.11. Then for middle age, we have 6. The frequency is 6, then representing 66.67%. Then for old age, we have 2 frequency value, then we have a percentage of 22.22%. So in total, we have a total frequency of 9. So this can show you the distribution of frequency among the 3 categories of age for old, young, and middle age. So this is also another way for you to analyze further your work if you want to interpret, show the distribution of age. So further, what do we want to do? I think this is the same command. We don't need to no. The next thing that we want to see the relationship between age and sex, the age category and sex. So let us see what it is the output related to this. Here, actually, we want to see whether females more concentrated in older age or males more in working age group. That's what we want to see. So we write this command using the tab command again, age, then sex, the row. That's the command. So we execute because we are using do file. So this is the output. This is for the out. This is the output for the age category for young. We don't have any female under young category. We only have one male under the young category. So the total frequency for respondents is 1. For middle age, we only have one male for middle age, representing 16.67%. Then for male, we have 5 frequency value, then representing 83.83%. And in total, we have 6 respondents under this age category, middle age, representing 100%. Then under the old age, we have 2 male under the old age. Then we have no male under the old age, having a total frequency of 2. So in total, we only have 3 males representing 33.33%. Then we have 6 male representing 66.67%. So this is also a way of doing a further analysis of your data. What else do we want to know? Having understood the number of females and males in each of the categories, what do we want to know next? Maybe we may want to have a simple regression. You may want to do a regression analysis under this. We don't need this, is the same thing, so we don't need to waste time on that. I think also this is very important because we may want to know age group versus education. We want to know whether older people likely have less education or younger people more in school, as the case may be. We want to know the distribution of age in different educational levels. So it is also important to analyze this. So we type age well. We type the variable the way it's supposed to be. We execute. Then let us see the outputs. This shows relationship between age categories with the level of education. So for younger group, we don't have any young person on the non-level of education, but we'll have one young person under grade 7 and no young person having high level of education, university education. So the total frequency here under the age category, young category, is 1. For middle age, we have 3 middle age respondents that have no education. 3 respondents that have no education, representing 60%. Then 1 respondent representing 20% that has a level of education of 7, and 1 also for high level of education university, representing 20%. So total exponent of frequency here is 5. For old people, we only have 2 exponents with no level of education. No old person falls under grade 7, and no old person as well falls under grade 10 level of education. So in total, under non-level of education, we have 5 individual respondents representing 62.50% that have no level of education in total. Then 2 individuals fall under grade 7 level of education representing 25% in total. Then 1 individual at university level representing 12.50%. So this is also a very good output that you can also do analysis when you are doing your actual data. So let us also have a simple regression and see how it comes out. A regress, a duke should be typed well. Let us type the indicator the right way. So our duke has been renamed to a duke in caps, then also age in caps. Then we have sex with initial capital letter. Then we have age group. So this is okay. So the idea is representing that Stata should treat this variable, sex and age group, as categorical variable. So that's what I stands for. So let us execute this and see what is our OLS output. Multiple linear regression model. Let us see what is the output for this. It is not well. A duke, age, so let us see what happens. We alight, we execute. Yes, now we've got it right. Got it right. So we regress education age, I.sex, I.age underscore group. These are the indicators. So I told you earlier that I represents implies that Stata should treat this variable as a categorical, these 2 variables as categorical. So this is the output. For basic analysis, you can see that the F statistics is not significant. Although the R square is halfway, 52%, then the adjusted R square is low. So this a simple output tells you that actually this model is not significant for policy recommendation. And let us come forward and prove that. And you can see the coefficients. They are not significant if you look at the p-values. For age, having a coefficient of 27%, but it doesn't influence education because it's not significant. Then as well, this is 64%, the p-value, far way above the accepted significance level. So this also does not influence education. It's positive, but it does not influence education. The age categories for middle and old, we see that for middle, it has a negative relationship, but it does not also influence education. Then as well, the age group, the old group also has a kind of negative relationship, but it does not also influence education. Of course, the young group is not significant, so I think the system omitted it because maybe there is a missing value. Yes, of course, there was a missing value. If you come back to these outputs for young people, so it's like this one is not significant. So the output is missing. So the system doing the operational process, the young age is omitted. So that's what it is. So the model actually is not significant for policy recommendation because most of the indicators are not relevant. So it's a learning process that you are running a survey, then survey data, and the output looks like this. And you'll be able to understand that this result is not relevant for any policy recommendation or for policy interpretation. So maybe you either increase your data size, the sample size, because this is just a small sample size. Maybe this could be one of the factors. You may increase the sample size and see what will be the output later. So with that, ladies and gentlemen, thank you very much. I've done one video on simple data estimation, working on cleaning and preparation of data. And the second video was purely on simple data analysis, descriptive statistics. And video part 3, actually, which is this current video, purely focusing on further analysis or focus on age categorical analysis. So that's what we've done. Thank you very much. Join me and make sure that you share, you comment, and you support the platform. Thank you very much.